Talk amongst yourselves. He literally said everything.
You were doing the same thing. I'm not. You know what? So hard on me. You didn't choose. Whatever. Me? Not you. Yeah, you were a lot quicker than I was. Final words. Oh.
Does it feel better? All right. Did it feel better? Did it feel better? No. Why is there just some slime in there?
Hey, this is not going to turn into every 5 seconds I'm going to make another personalized invitation for you to behave. You're in 9th grade. I know I've said this multiple times. You're in 9th grade. You know what's the right thing to do. You know what's the wrong thing to do. It's not a surprise when someone gets into trouble. Do the right thing. I'm never going to correct you if it's something as simple as someone drops a pencil and they're saying thank you. And I say, get out of here. You shouldn't be talking. When I ask you 4 times to be quiet and I don't get quiet, that's too much. 2 I can live with, not 4. Can we get some work done now? All right, let's get some work done. All right. We're going to go over real quickly. Someone had a question. Who was it?
That was me.
What was it on number?
Oh, never mind. I explained it to him.
All right, thank you for that. All right, here we go. Number 1, 4.84 times 10 to the 4th. Number 2, 2.5 times 10 to the negative 3. Number 3, 1.9 times 10 to the negative 3. Number 4, 3.5 times 10 to the 4th. Number 5, 4 times 10 to the negative 2. Sometimes people will look at number 6 and like, what do you mean? That has to be inside. Remember, first number has to be between 1 and 10. First number is not between 1 and 10. So 7 times 10 to the 1st. Seems kind of silly, right? But it's just to show no one would put 70 in scientific notation. Number 7, 2.62 times 10 to the 6th. And number 8, 5.1 times 10 to the negative 5. If you got some of those wrong, with exception of 7 and 8. 7 and 8 were what we finished yesterday of when you have a number that sort of looks like it's in scientific notation, but it's not. You got 1 through 6 correct. We're where we need to be. Number 9, I'm going to count zeros here. So 0.000021. That's a lot of zeros. Number 10 is 110. Number 11 is 83,000. 83 and 3 zeros. Number 12, 2,900. Number 13, 40,000. Number 14, 0.0000953. Number 15 is 480. Number 16 is 908,000. All right, and all the rest were the ones that where we kind of had at the very end there of it. It looks like in scientific notation, it's not. Just remember, if it's a small number, the exponent gets smaller. If it's a big number, the exponent gets bigger by however many decimal places you need to move it. Number 17 is, well, I remember who was this? Did I work on this? Anna? Was this the one that we worked on? Yeah. Yeah, 17 is weird. It's 2.8 times 10 to the 0 power. That seems kind of silly, but that's the answer. Number 18 is 8.9 times 10 to the 1st. 19 is 2.7 times 10 to the negative 2. If you're getting these wrong, hopefully you see why you're getting them wrong. Number 20 is 2.6 times 10 to the negative 4. Usually if there's a mistake, there's negatives involved. 21, 1.1 times 10 to the 2nd. 22, 9.2 times 10 to the negative 3. 23, 3 times 10 to the negative 1. And 24, 7 times 10 to the 1st. And that's it. All right, I need you to pass out and collect Talk amongst yourselves. Let me take care of one more problem and then we'll get going with class. It's a Friday. We can all make it through Friday.
Except when he tripped over me and fell on top of me.
I feel for you.
Oh, so it's just gonna be distributed property?
No. Sorted, no. No. Distributive property is when you have multiplication and addition or subtraction. All right. Yesterday we did this thing called scientific notation. I showed it to you. You guys were like halfway through class. You're like, I got this. You can stop talking, that sort of thing. That's good. Thanks. Thank you. What we did that for, it was a review. It wasn't an Algebra 1 thing. What we did that for is today's class. So today's class is the reason we have scientific notation homework from the book. It's not that many. You don't need to do more than 5 of these to get the idea.
Oh, I have to write that down.
Not this part. Last year, all we did was put numbers into scientific notation, put them in standard form. On the test, there'll be, I don't know, 2 questions on that each. Next Wednesday. We'll do 2 review days because this chapter as well was a somewhat of a butt kicker. Easier than the previous chapter, but still pretty hard.
You said that this was easy. Why is it only 5 questions?
Because if I gave you 10, you'd be, why did you give me 10 of these? I figured it out after the second one.
Well, normally when you just don't have a lot, when you don't have a lot, it means they're hard.
If I give you a lot, it's because there's a lot of things you need to practice. So I only give you a few. It's either because it's word problems or it's because you'll understand it after the second or third one.
Okay.
I mean, I feel like giving you 2 problems would be not enough, but giving you 10 of them would be too many.
2 not enough.
All right, here we go. Scientific notation. Why doesn't that say B? Is this the right class? This is the right class. That should say 10B. Yesterday, we learned how to convert very large numbers and very small numbers into scientific notation. Now, Julie was online, but Sierra, you were not here. This was that process, same class we had last year, is I move a decimal from its original location until I get a number between 1 and 10. And I count how many times I moved it. As I recommended to you guys, the loop thing, I saw in a lot of your papers, that's fine. There's nothing inherently bad with the loops. I just find more students make more mistakes with loops than if they simply touch between the 2 numbers, they tend to make fewer mistakes. So that time I moved it 7 positions. Large numbers get positive exponents. Squeeze these 2 numbers together, 4.52 times 10 to the 7. For small numbers, the only thing that changes is that the exponent will be negative. Once again, I'm moving the decimal place 1, 2, 3, 4 to create a number between 1 and 10. Remember, it can be 1, it just can't be 10. Okay. I start off by saying why we do scientific notation is because you'll see next year, well, a little bit in chemistry, but definitely in physics class, because you deal with really large numbers and really small numbers. The small numbers, you don't deal much with too many large numbers in chemistry, occasionally moles, that sort of thing. But usually in chemistry, you're talking about very small things. So you will do some math next year with either large or small numbers. And I said, hey, the next star next to our sun is Proxima Centauri. And in meters, it's that thing right there, big honking number. If you're a scientist that deals with those things, you got to add, subtract, and multiply and divide with numbers that look like this. It's very cumbersome. If you work in the medical field or chemistry, you're dealing with very, very, very small things. So if you have to add, subtract, multiply, or divide with very, very small numbers, well, you're going to make a mistake because there's just too many zeros. You're either going to write it wrong or you're entering your calculator wrong. So a long time ago, they came up with this method to deal with large or small numbers or both and be able to quickly, and I mean quickly, you're going to see some of these, we'll be dividing like a trillion by a trillion. And we'll be able to do it in our heads in under 5 seconds because of this thing called scientific notation. We don't teach it to second and third graders because they're not ready for it. They don't even know what an exponent is. That's why we can't do this for them. So why do we do this? Is it just makes the process very easy. This is today's class. It's going to be a quick class. It's also Friday. All right, so we'll do multiplying, then we'll do dividing, and lastly, we'll do adding, subtracting. So how do you multiply with scientific notation? If I give you this number, is that scientific notation?
Yes.
Is that scientific notation? If I ask you to multiply them together, Josie's kind of already got this figured out. Well, squeeze them together. And luckily for us, what's in between every single thing? And multiplication is commutative. 2 times 3 is the same as 3 times 2. I can multiply them in any order I want. What would be the easiest way to multiply that? What?
Do the tens together.
Do the 10s together. Do the 2s together. Watch how easy this turns into because we're using the commutative property. If I move this 2 next to the 6.4, if I move the 10 to the 5 next to the 10 squared, we can use what we use in this chapter. Hey, same bases. What do you do with the exponents? What's 2 times 6.4? You can do that in your head. 2 times 6.4 is?
12 point.
I'm not claiming you can always do it in your head, but in this case you can. 10 to the 5th times 10 squared gives me? Is that number in scientific notation?
No.
No. What do we got to do? Big or small number? If you move the big number, that means that 7 becomes bigger or smaller. By how many numbers? How many are we going to move it? How many? How many are we going to move it over to make that number in scientific notation? It's 12.8. It's not inside. It's bigger than 10.
Yeah.
So how many decimal places are we going to move it? So that now becomes, if you move it once, that becomes, there we go. That's the math that allows us, but the reality is most people go from this step to that step very quickly. Okay, let's see that again. Hey, it works with negative exponents as well too. Squeeze them together. Move them. Can anybody do that in their head?
15.30.
It's close. You just got to carry your 3.
16.
You're carrying 3.
18.
18, yeah. Hey, what's that turn into? Somebody?
What?
What's that turn into? Negative.
Yeah.
Okay.
Negative.
Is that in scientific notation?
Yeah. No.
Big or small number? That's going to make this one get bigger by 1. What's 1 bigger than negative 16? A lot of people say that. Think of a number line. So that's the one that will kick your butt when there's negative. Okay. When there's negative involved, it actually the number magnitude gets the number gets smaller, magnitude gets bigger. Yeah.
My brain just malfunctioned. What's 8 minus negative 10?
18.
8 to negative 10. Yeah, but then I did it on my calculator and it said it was 2, so now I'm confused.
Wait,
I don't know what you typed in your calculator. You typed it in wrong.
I typed it in like this.
If you typed it in with 1 negative, then it would be negative 2. But you said 8 minus negative 10.
Yeah, so it would be 18.
Yeah, if you wrote 8 minus 10, that's negative 2. All right, hey, what's the difference between this one and the previous one? I don't know why. This is what it more looks like in homework. They just write it like this. Hey, it's the same problem as this one. Multiply this thing times this thing. So what are we going to multiply together to make our life easy? 6 and 4. You can do this in one in your head. So what do we get? What?
24.
24 times 10 to the
I'm a genius.
no 10th power. But that's not in scientific notation. So what do we have to do? So therefore that 10 now becomes, so 2.4 times 10 to the 11. Easy or hard? Now you have to stop me since you heard 4 people say, oh, that's really easy. And you might be sitting there right now saying, wait a minute, I have no idea what you're doing. Is there anyone out there that that's the case?
How do you times the 2 numbers?
Because it is multiplication.
And not the 2 times?
Well, remember, the rule for multiplying with exponents is the base stays the same and the exponent changes. So to answer your question, what is 2 to the second times 2 to the third? Well, how many 2's are right here?
2.
1, 2. How many 2's are here? 1, 2, 3. So that's 2 to the 1, 2, 3, 4, 5. 2 to the 5th. We don't change the base, we change the exponents. That's why. All right. Cool. So that's the welcome to the club. Scientific notation that makes your life easier. And this is why a
That's really
scientist,
cool.
when they say something like, oh, it's 63 billion miles away, and we're doing this particular number, and they're able to add, subtract, multiply, divide very quickly in their head. It's not necessarily because they're a genius, because they're doing scientific notation. Yeah,
But they get calculators, right?
probably. So.
It starts on the right and then you go
Remember, to be in scientific notation, this one looks like it, but the first number has to be between 1 and 10, and that's 24. So we're moving at 1, but we ask ourselves, is 24 a big or small number? Big number, right? Small number means it would be a decimal number, and that's not a decimal number, right? Or it's smaller than 1, I should say. So therefore, that will make the whatever's underneath my hand here exponent get bigger by however many decimal places. So you only had to move it once, so whatever's underneath here is going to get bigger by 1. If we had to move it 2 decimal places, it'd get bigger by 2. If it was a small number and we had to move it 1 decimal place, then that number would get smaller by 1, or 2 decimal places smaller by 2. All right, you want to do this together, or you already got the answers? See what I mean about scientific notation? It's not bad at all. You can do this in your head. That's going to give me 24 times 10 to the negative 6, right? Same sign to add. But 24 is not in scientific notation, so I got to move it 1 decimal place, which would make my exponent get bigger by 1. We were at negative 6, so negative 5. You got to get bigger, not smaller. Okay? Notice, yeah, but think of a number line. Negative 7 is smaller than negative 6, not bigger. So negative 5. Once again, I said, if you're going to make a mistake, it's going to be because there's negatives involved in the exponents. You're not thinking it through. Yeah.
In the book it says 10. There's an answer with 10 to 0. I thought that couldn't happen.
Anything to 0 power is 1. This was the Anna question the other day. So would I ever really do that? Well, that's a math teacher question. Scientists would just say, well, anything to 0 power is 1. So just leave that part off. But yeah, in the math book, they're going to have a question like that. Anybody can do 5 times 3.1 in their head?
Yes.
How much?
15.
Sorry,
15.1. You did that in your head, right? By the way, you just multiplied.
Wouldn't it be 15.5?
Yeah, we're 15.5. Yeah.
15. What did she say?
15.5.
All right, 15.5. You're right.
You were close.
You just multiplied. Kaylee, you just multiplied that in your head, although you got it wrong. But you almost got it right. You just multiplied that. Look what I wrote. 0.05 times, I got to write how many, times 310 million in your head. It's crazy. And that's the power of scientific notation. By the way, what's the final answer? So she got 15.5 times 10 to the 6, but 15.5 is not in scientific notation. We need to make it move once. Therefore, that becomes a. So I'm still going to claim you did the whole darn thing in your head. You multiplied 0.05 times a couple million. I don't know. To me, that just sounds incredible that you can do that in your head. You tell that to a 3rd grader, and they're like, "That's not possible." So much of math is just little tricks. All right, anybody? 1.5 times 4? 6 times 10 to the 23rd, and that one is in scientific notation. You're done. By the way, what did you just multiply in your head?
A really long number.
A really, 1, 2, 3, 4. So 1, 2, 3, 4, 5. That would be 400,000 times. Oh my word! I mean, I need the whole whiteboard to put that many zeros, and it's not 18 zeros, right? It's 18 decimal places. I mean, that's a number that's this long, and you multiplied it by 400,000 that quickly. That's why we use scientific notation. So next year in science class, when you comes up to scientific notation, you're going to say, yes, I remember learning this. Show it to me one more time. You'll probably somewhat forget it, but you're going to remember it quickly when you have this again in science class. When you get to junior year, when you take physics, this is used every day, as you're always measuring little tiny things or really big things. And you're multiplying, dividing, adding, and subtracting them together. I don't think you can put 18 digits in your calculator. You can certainly put 5 digits, but you can't put 18 digits in your calculator. All right, so we just did multiplication. The next one we're going to do is division. Okay, so let's do some division.
It's just as easy.
Oh wait, I got to do a power to a power first. Power to a power. Hey, what's the rule for power to a power?
You multiply them.
Multiply what?
The exponents.
Exponents, powers.
And then you do 3 times.
3 is to what power?
1.
So we can't forget that everything gets multiplied by this power. So that's going to give me 3 to the third times.
10 to the 18th.
Is that in scientific notation?
Well, couldn't you do 3 times 3 times 3?
You can, which is what?
27.
Is that in scientific notation?
No.
So what's the final answer?
2.7 times 10 to the 19th.
You guys are getting deep pros at this, right? Negatives, all it changes is the fact that you're going to have negatives rolling around. 4 is still to the first power. So that's going to give me 4 to the times 10 to the 9th. Negative 9, sorry. 4 to the third is 4 times 4 is
16.
Times another 4. Somebody?
Huh?
Not
64.
64. Okay. Big or small number?
Big.
It's going to make it bigger. Kaylee, back to you. That's a big number. How many decimal places? How many decimal places we got to move it? Just the 64. Just the 64. We got to make it into a number between 1 and 10. How many? So big or small number? So we need to make this, whatever's underneath my hand, bigger by how many decimal places do we move it? So make it bigger by 1. Which one? Negative 8. Okay. Got it? Okay. The only time it will be the opposite of that is that number was very small. Right, then you would make that number small. All right, are we doing this together?
No, please skip.
All right. This one's a little bit more challenging because it's a decimal. So I wouldn't expect you to be able to do that in your head. So this one will require a little scratch work.
1, no. 3 times 3 times 3.
No, it's 3.1.
No, I know that, but then you realize oh yeah.
So that one will require a little bit of scratch work off to the side. 3.1 times 3.1, whatever that answer is, times another 3.1. I'll give it to you. It's 29.79. It's got to be bigger than 27. Remember, 3 to the third was 27. So it's got to be a little bit. It is just a little bit bigger. Am I going to pick on Kaylee again?
No, you're gonna pick on Chris.
Chris.
Please, Chris.
Yes,
29.97. Big or small?
it's quite big.
Okay. How many decimal places you got to move it to make it into a scientific notation number?
Oh, twice.
Okay. You move it twice, it's 0.29. Okay. So if you move a big number by 1, you make the exponent get bigger or smaller by 1.
Oh, did you ask me a question?
Yes.
Oh, I thought you were stating something.
Yeah. No, that was the raising of my voice at the end, or the raising of the tone of my voice at the end.
It gets smaller. No, bigger.
Okay, you said both. Which one?
Bigger.
By 1. So make that number get bigger by 1.
The 7.91. So you should make that number get bigger by 1.
It's not what it says. You make the exponent get bigger by 1. So what's the answer? In scientific notation. We go back to start class, what I said. You're not going to sit there and watch me do math and you are clueless. You're going to stop me and say, wait, stop. What did you just do? I don't get it. Julie does it every single day when she's lost. I don't mean every day. I mean, when she's lost, she literally says, stop. I don't get this. That's what a student should do.
I have some idea.
Every single kid, I'm going to make that bet right now. Every single kid right now knows what to do. Do you?
Yes.
Then tell me what to do. Don't tell him the answer. Let him struggle.
You can't.
That's the part of the learning process. Chris, and I'm going to go back to what I started when I asked you the first question. You paid attention?
Yes.
Big or small number? You told me.
It was a big number.
Okay, how many decimal places to put in scientific notation?
1.
If you move it once and it was a big number, you make the exponent get bigger by 1. If it's small and you move it once, you make the exponent smaller by 1. So what are you going to do to the exponent?
Make it bigger by 1.
Do it.
29.
You
No,
scientific notation.
2.9.
Perfect. Keep going.
70. 791. 9.
Keep talking.
X. 10.
That's not what you said you were going to do.
Sorry.
You told me.
Sorry. X 10 16.
Okay, times 10 to the 16th
Yes,
power.
times 10.
Okay, you just won another problem. Congratulations. All right, here we go. Power of power. This 3 goes to every exponent. What's the exponent on the 4 right now?
There's no exponent. Oh wait, there
If it's not one, if it's not there, it's
1.
3 times 1. 3 times negative 15. Big number, negative 45. Okay, good. 4 to the 3rd is 4 times 4 times 4. Yes?
Yes.
4 times 4 is
Not 8. It's 14.
16.
16.
Times another 4 is 64. Okay, we're on this step. Is that number in scientific notation? What do we got to do?
Decimal.
How many places?
Twice. No, once. No, twice.
Which one?
No, twice. Twice.
Okay, watch me, Chris. You said move it twice. We're gonna move it twice. Once, twice.
Oh, no, that's never mind. Once.
One time. Now, was that number a big number or a small number to start with?
Quite big.
Okay, so that means the exponent is going to get what, bigger or smaller?
Bigger.
By, okay, now this is Kaylee's question. Let's see if you can do better. I'm going to uncover the exponent. You're going to make it get bigger by, make it get bigger by 1.
46. No, sorry. Negative 44.
Questions? Piper, yes, no? The one that will kick your butt is when it's negative. Nearly every kid that doesn't have a firm grasp of their positives and their negatives will tell me negative 46 when I say get bigger by 1. You got to think of a number line, Julie. Okay. Tell me what you got after you did this part. You're done. That's it. Okay. What were the 2 exponents to start with? Okay, negative 8 times 4 is negative 32. I'm going to have to look at the problem. All right. What's the number? 27. We're not doing this. We're not doing power of power. We're just doing straight up multiplication. Straight up multiplication, what do you do with the exponents? You just add them. So 27, what 2 numbers am I adding? That's negative 4. I don't know either. You added 8 and 4. One of them was negative. That's how you got it. All right. Questions, anyone? All right. Do we need to do this?
No.
Rowan, you got this? Pick one. Top, middle, bottom. Which one? Top. 3 times 1? 3 times 6? So we get 2.5 to the third times 10 to the 18th. We good? Can you do that in your head, or is that scratch work? That is absolutely 100% scratch work. So once the, oh, I didn't do it. Once the scratch work is done, let's see. 2.5 times 2.5. By the way, that's 25 times 25. Move the decimal place twice. 25, carry your 2. 10 plus 2 is 12. Bring down the 0. 10, 4, 5. I'm getting 625. 2 decimal places, that gives me. Okay. Then we got to multiply by another 2.5. 5 times 5, 25, carry 2, that's 12. Carrying 1, 31. Bring down the 0, 10, 5, 12. 2, 2, 6, 5, 1. 1, 2, 3 decimal places. 1, 2, 3. Good Lord, Rowan gets a point. Thank you. Good job. All right. I got 15.625. Well, 0 and 5 is still 5. I did 1, 2, 3.
In the answer, it's
1, 2, 3 decimal places.
Yeah, that one.
1, 2, 3.
Yeah,
About the next step.
Oh, God. Okay, okay. Yeah, right. So here's the deal: 15.6 and some change, right? And then you got to say one more.
Yeah.
So that's going to change from an 18 to a. And so the final answer, can you put all that together in your head?
1.5.
And we'll stop right there. 1.5 times.
10.
There we go. There we go. You got it. What was the last thing I said we would do?
No, division and adding subtraction.
Yeah, we got division and subtraction. Okay, here we go.
We just hurry up and speed run it.
Yeah.
Okay, you tell me. Can you do this quickly in your head?
Yes, 8 times 4 is 2 times x.
That's not 8 times 4.
8 times 4 divided by 8 equals
What's
2.
4 divided by 8?
2. Oh, wait, 8 divided by 2.
That's not what it says.
That's not what he said. 4 divided by 8.
4 divided by 8 is 0.5, half, right? What do you do with the exponents if you're dividing? So what's that going to give me?
10 to the third.
Okay. Is that in scientific notation?
No.
Big or small number, Chris?
Small.
You're just not paying attention. That's a small number. So that's going to make my exponent get what? Bigger or smaller? You said both. Smaller. How many decimal places? So I need to make my exponent, which is, hey, that's not the bell.
That is the third bell.
Oh, no, you're right. I'm wrong.
Ah,
All right, stop. Stop. We got 2 minutes and I'm not done. Sit. Okay. Small number, 1 decimal place. I got to make this smaller by 1. Well, 5 minus 2 is,
3.
and I got to make it smaller by 1, so not 4, but 2. Okay. So, non-scientific notation. Hey, make it smaller by 1. That gives me a 2. So 5 times 10 to the 7th power. All right. That's how division is done. One thing left, and that's adding, subtracting. All right. Let's take a look at adding, subtracting. Adding, subtracting. Here we go. There are no of these on homework, but I got to show you adding, subtracting. Adding, subtracting. Okay. Here are 2 very large numbers that I'm trying to add together. They're both in scientific notation.
6.7.
When you add, do you ever do anything with multiplication? So
6.7.
all I do is add the 2 numbers and rewrite. But there's one caveat. You can only, and this is for adding and subtracting, you can only do this if, take a guess.
The powers are the same.
Powers are the same.
Oh.
So if, it's a big if the powers are the same, just add these 2 numbers. Do it.
6.7
Times 10 to the,
10 to the 5th.
you just added a whole bunch of big numbers together in less than 1 second.
Easy peasy.
But obviously the question is, oh, same powers? So times 10 to the, so what's the big but here?
If
What if
the
there isn't
powers
the
are
same?
the
What if
same?
they're not the same? So the big but is, it works for subtraction too. So the big but here is, what if they're not the same? Okay, it doesn't, it still makes it easy, just not as easy as what we just did. Clearly, guess what we need to do? We need to make the powers the same.
How would you make the powers the same?
You already know this.
Add 2 to the opposite, make it
In before, when we changed this, we messed with this, we just do the reverse process. You either make the 15 a 13, or 13 or 15, which one? What?
Make the 15 and 13.
We make a 15 to a 13, stop. We're almost there. You make this smaller, you gotta make that bigger. If you make this bigger, you gotta make that smaller. So you wanna turn this into a what?
13.
That's how many decimal places?
2.
Make this bigger by 2.
632.9. That's 132.
So add this to that.
632.1 times 10 to the 13.
Is that scientific notation?
No.
How many decimal places?
Oh.
So that's gonna turn that into,
15.
you still did some pretty gnarly addition pretty quickly without a calculator, somewhat effortlessly. And the effort only involved moving a decimal place. All right, have a good lunch. You're still eating in here. All right, let's see. Mike, are you online? You are not online. Mike, if you have any questions about this class, send me a chat or email.